Vulnerability data about open source software should be open too. This is the title of this presentation, but also its conclusion. In the next 20 minutes or so, I will try to explain how my colleagues and I came to this conclusion. My name is Antonino Sabetta. I am a senior researcher at SAP Security Research, and my interest in security of open source software started about 7 years ago, when I joined my colleagues Serena Ponta and Eric Plate, who at that time were already doing research on novel ways to detect, assess, and mitigate vulnerabilities in open source libraries, particularly those that are dependencies of enterprise applications like the ones that SAP makes. In the context of this research, in 2014, we started working on an internal tool that would eventually be adopted across SAP to secure all Java projects and run over 150,000 scans each month. That tool was released as open source in 2018 and is now known as Eclipse Steady. Quite some time has passed since then, and if we look back at what has happened during these years, there are a few things to remark. The growing relevance of open source software for commercial products was quite visible back then, and the trend is still continuing. Today, as much as 80 to 90% of commercial software products rely on at least some open source components. At the same time, the number of vulnerabilities reported for those components has grown as well. And managing these vulnerabilities, that is identifying them, assessing their impact, and mitigating them, is by now a major concern in the software industry, as confirmed by the fact that this threat was included by OWASP in their top 10 list, and it remained in that list since 2013. The root cause of several major data breaches in the past few years, you might all remember Equifax, for example, was due to vulnerabilities in open source components. And lastly, to confirm the relevance of this problem to the industry, a new market of software composition analysis tools has emerged, particularly in the past 5 years. These tools may use different techniques to perform their analysis, but they are all based on some sort of vulnerability database. The most popular of which is certainly the NVD, National Vulnerability Database, which is the de facto reference database of publicly known vulnerability advisories. Each of these advisories is identified using a standard called Common Vulnerability Enumeration, or CVE for short. And anyone can request the creation of an advisory by reserving a CVE identifier. For example, developers of the affected product, or even independent researchers who have found a vulnerability in that product. At this time, the NVD contains quite a number of distinct CVEs, part of which also refer to open source products. And the NVD also complements advisories with severity scores, called CVSS, as well as with a list of affected products, named CPE. A positive aspect of the NVD is that it is public, so anyone can use it and it is searchable. On the other hand, when using the NVD for the purposes of vulnerability analysis, a few shortcomings become apparent. To give an idea of what are these shortcomings, let me take an example, a CVE affecting Eclipse Mojarra. Here on the left, you can see the content of the CVE. As you can see, it mentions a few details, for example, the name of the function and of the file where the vulnerability occurs, as well as version intervals that are affected by this vulnerability. Now, when using this kind of information for vulnerability assessment, and in particular application-specific impact assessment, there are a few problems. First of all, the description is pretty short and high level, so it doesn't contain enough information for a developer to determine whether or not this affects their project. Second, this might impact a dependency that is a transitive dependency. Now, not only transitive dependencies are a bit difficult for developers to understand because they might be resolved in very sophisticated ways, but also it's virtually impossible for anyone to know the names of all the functions in all of these dependencies. Third is a problem of naming and also granularity. CVEs are assigned to CPEs, so to products, so to large projects as a whole, for example, Mojarra in this case. But developers typically import in their project packages. So they refer to jars and not to project as a whole, not to CPEs. Also related to this problem of granularity, there is the fact that Because vulnerabilities are assigned to entire projects, but developers might include subcomponents, when using CVEs for vulnerability assessment, one would have very frequently false positives. Because CVEs are created and maintained manually, they tend to be error prone and also lag behind the actual data when vulnerabilities are discovered and fixed. The coverage of the MVD is also not very good, especially for certain ecosystems. I mentioned that CVEs can contain errors, and in fact, with Eclipse Steady, we found an error exactly in this CVE, where we detected that the actual version should be 237, not 235. Now, the approaches to vulnerability detection can be classified into broad classes. The first one is based on metadata. The tools in this class, of which OWASP dependency check is a good example, try to match the CPEs as found in the CVE, so the product identifiers, onto strings that can be found in the metadata, in the artifact names, and other strings in the artifacts that are embedded in a project. Now, the advantage of this approach is that they are rather lightweight. For example, OWASP dependency check is a standalone tool that one can download, synchronize against the MVD rather efficiently, and then run against their own project. On the downside is that accuracy is not very good, and for the reasons I explained before, OWASP dependency check has quite a few false positives and false negatives. A completely different approach uses instead source code level information, and Eclipse Steady belongs to this family. What Eclipse Steady does is it represents, first of all, a vulnerability in terms of the code level changes that were done to the source code in order to fix that vulnerability. With this information, Steady checks for the actual presence of the vulnerable snippet of code inside an artifact. And besides the detection of the vulnerability, this also has other advantages. In particular, Steady can conduct very sophisticated reachability analysis combining static and dynamic techniques. So basically it constructs a call graph of the application at hand and all its dependencies to determine if from any of the methods of the application there is a path on the call graph that reaches to the vulnerable method. This is done combining both static executions, the black arrows in this figure, as well as dynamic executions, for example, traces collected during test cases or integration tests. And the two are combined to maximize coverage. Also, based on this code level information, Steady can support the update to non-vulnerable dependencies, trying to minimize the effort required for the update. A downside of Steady is that it requires code level information about vulnerabilities, and this information is not easy to obtain. In particular, it's not available in the MVD. So to summarize, code-based approaches improve over those based on metadata because they're more accurate. The problem is the data required by code-based approaches is not easily available. In particular, the MVD does not have it, and there are no other public databases that contain comprehensive and high-quality information at that level of granularity. This is quite ironical because in principle, all the information we need is readily available in the source code repositories of each project. There have been attempts to automate this mining of software repositories using machine learning, both by our team and also other researchers. But in our experience, the maturity of these approaches is not adequate for practical application. In the meantime, commercial vendors have stepped in not only with their own tools, but also with proprietary databases that come with the tools. Now, these databases are sometimes free to browse. However, they are not freely available and they are not adequate to support vulnerability analysis the way we want it, which is the open source way. We have seen so far why having detailed code level information about vulnerabilities is essential to operating a tool that is code-based, like Eclipse Steady. But the motivation for the content I'm about to present doesn't come from abstract considerations. In fact, in the past 4 years, while operating Eclipse Steady at SAP, we have spent a considerable amount of time mining software repositories to construct a vulnerability dataset that we could use to feed Steady. So far, we have collected about 1,600 distinct vulnerabilities, but this activity is extremely time-consuming. If I had to summarize the lessons learned during these years collecting data in software repositories, I would say that we understood that no single entity can be successful at this task. And in fact, because of the very nature of the problem, a collaborative approach makes much more sense. So Project KB is our attempt to create an open, collaborative, trustworthy knowledge base of vulnerabilities and their fixes in a way that different parties can collaborate. Each of them can maintain a Git repository in which they could store what we call vulnerability statements, which are basically plain text statements about their beliefs as to what are the fixes for a given vulnerability. These are statements that are machine readable, but also human readable, very simply. And the issuers of these statements, what I call data producers in this slide, maintain full control over the repository where they store their statements. So it's completely okay that different issuers say different things about different vulnerabilities. They might have different views, they might believe different things, so they might have found different evidence. But it is in the hand of the data consumers to decide which repositories and so which issuers they want to trust. And also, given all the necessary information, they could decide which reconciliation policy they want to apply to aggregate information from different sources. Of course, we also provide tool support to make sure this creation, aggregation, and validation of statements happens in a predictable way. Let's take a look at the scenarios that we want to support. And let's distinguish two different phases. One is about publishing statements, the other one is consuming statements. So who would be interested to publish statements? Well, as it happens right now, where independent security researchers find issues about products and they report them to the MVD, well, the same can happen with Project KB. They would represent their findings in statements and put them in their own repositories. Also, as we do at SAP, other companies might be maintaining their own databases of vulnerabilities, and it would be very useful if these would be maintained as repositories of statements that can be used then by others. Finally, a very natural way to apply Project KB in practice and to make it useful is to have project maintainers themselves publish information about their own projects as statements. Basically, individual projects or even organizations like the Eclipse Foundation could have a central place where they would put all the advisories about the projects they control. And these advisories would be not only plain text as they are right now, but they would also contain precise statements about the fixes to those vulnerabilities. On the consumer side, of course, the main use case we have in mind is developers that use software composition analysis tools, such as Eclipse Steady. They would be able to import the information from a variety of repositories and aggregate them in whatever way makes sense for them. But we are also aware that many researchers in academia, but also in industry, are interested in studying how real-world vulnerabilities and their fixes look like. And this is a tremendous help in coming up with better techniques and better tools to address those vulnerabilities in the first place. Let's take a look at the big picture of how Project KB functions. At the bottom of the slide, I reported the three types of publishers, of issuers of statements I mentioned. So an individual researcher, security researcher, a foundation like the Eclipse Foundation, or Alice, maintainer of a given project. They would all publish statements stored in Git repositories that they control. On the consumer side, at the top here, the first operation that the consumer would do is to pull the remote sources in local replicas, from which a merge policy, one or more merge policies could be defined to aggregate the content of these repositories into one single aggregated data set of statements, from which An export operation would produce data in a format that is amenable for import, for example, in Eclipse Steady, but also in other formats, XML, JSON, CSV, or other formats for other tools. Of course, the consumer can also create statements and publish them in another repository that they control. Let's take a look at how statements look like. As I said, statements are supposed to express the knowledge or the belief of a given entity, an issuer, about a particular vulnerability. The core of the statement is this section, the fixes section. And this is what Eclipse Steady, by the way, really needs. And it is basically a list of commits in repositories that fix the vulnerability identified here at the top. Our format also allows to specify claims about individual artifacts. We are using PURL to indicate that the Maven artifact with this group and this ID is not affected by this vulnerability. And we also annotate the reason why we believe it's not. This can be any comment. And then we can have a bunch of notes with plain text. This is basically the text coming from the MVD, but also links to other resources. This is, as I said, plain text format. It is signed and it is stored in repositories that the issuer controls. Then it is the consumer that decides how to consume this and how to reconcile with other statements. To simplify things, Project kaybee also has tool support, and in particular a tool called kaybee that you can download from GitHub. It's very easy to install. There's nothing to install. In fact, it's just a single self-contained binary. You can download it for your own operating system. The first time you should run kaybee setup, which creates kaybee.conf.yaml file. And it's interesting to take a look at the content of this file because you will see here that in this particular example, we have two sources configured. Each of them is assigned a rank. And this rank can be used in the reconciliation step to decide which of the two takes priority. Arbitrary policies can be written using this information. For example, one could decide that a certain repository is to be trusted for statements about a given project, or that a certain source is the authoritative source for any statements. Right now, we have a strict policy that we have implemented, which is basically a policy that refuses to reconcile statements about the same vulnerability if they come from different repositories. And this is still useful because it means we can aggregate statements from repositories in a very straightforward way without too much magic happening under the hood. This section here of the configuration file shows how we configure an export target. So as I said before, statements are plain text. They can be exported by kaybee in a bunch of formats. This is just an example because as you see here, each section is a template applied to each statement object. And for those of you who are familiar with Golang text templates, well, this is a Golang text template. So basically, you see this is just iterated over each object, and the attributes of the object are used to flesh out the template in a concrete output. Other targets are possible. We have another target called Steady, which creates a script that can be used to import statements into a Steady backend. Other useful commands from kaybee are kaybee create, used to create statements. Kaybee pull creates a local replica of remote sources. Merge applies policies to reconcile the remote sources and creates the aggregated set of statements. As I said, ranks can be used to control policies, but any other information coming from the statements could be used. And the export command I just mentioned that takes a target attribute. In the example before, this would be target XML or Steady, but any other target could be configured by the user. Project kaybee is a very new project. It started just a few months ago, and it's very much in its infancy. Our main goal right now is to validate the idea and to get feedback from all of you. So the best thing you can do to help us out with this is to spread the word about this project and gather some critical mass around it. We need people that adopt the format and try it out so that we understand if it's really a good solution in practice. Of course, code contributions are very welcome. The kaybee tool is very rudimental at this time, but there are many things that we could do to improve it and to make it much more useful. And of course, contributing with vulnerability statements is the main way to make Project kaybee successful. We have collected at this time at SAP 1,600 distinct vulnerability statements, and we plan to release them all. By the time this presentation will be shown to you, probably all of them have been published. And of course, we want to continue developing the kaybee tool. As a complementary work stream, we are also working on tool support to mine software repositories and to identify fixed commits. In particular, we are trying to map and reconcile advisories from the MVD, so based on their content in natural language text, onto the fixed commits that correspond to those advisories. This is complementary because even if the Project kaybee format is adopted widely, we will still have a large backlog in the future of all the other vulnerabilities for which we don't know the fixed commits. So a tool like this is very useful. Okay, let me draw some conclusions and summarize what we saw in this presentation. The software industry at large needs very precise, efficient analysis techniques to deal with the problem of effective vulnerability management. Metadata-based approaches don't cut it because they suffer from too many false positives and also too many false negatives. And because the actual truth is in the code itself, code level information about vulnerability and their fixes is very important because it enables code level analysis. Gathering this information is quite difficult, cannot be done by a single party. Inherently, the problem needs to be addressed by a collaborative approach. We need to express vulnerabilities and fixes in a format that is open and for which tool support can enable publishing, sharing, and aggregating data in a very efficient, flexible, and trustworthy fashion. There are databases that are proprietary. We don't believe that is the right way to approach the problem. Proprietary tools that offer advanced techniques are a very good thing, but the data should be available to everybody because having the data allows progress in the field of vulnerability analysis and vulnerability management. Finally, it is in the interest of the software industry at large, including the open source community and the commercial vendors, to remove all the obstacles to a broad adoption of effective vulnerability management practices. Having tools like Eclipse Steady that improve the way we detect, assess, and mitigate vulnerabilities is one important step in this direction. However, the difficulty in obtaining comprehensive vulnerability data is still a critical stumbling block. We believe that the best way to overcome this stumbling block is by joining forces in a truly collaborative effort. We believe the best way is the open source way.
Hello.
Thanks for attending. I'm Antonio Sabetta. Today we also have Serena Ponte and Nick Platte to answer your questions. I think we can already start. We do have a question already. Do you plan to move Project kaybee to the Eclipse Foundation or another foundation? Otherwise, Project kaybee depends on SAP. Yeah, probably it's too early to decide. We can say that the history of Eclipse Steady shows that it sometimes takes some time to mature a project and to take a decision like that. I think what is best for Project kaybee is that it acquires a large user base. And if the Eclipse Foundation is helpful for that, probably that's a good idea. We have not decided that yet. It's very early. Project kaybee just started. It's a couple of months. Any other questions? Is it not yet another vulnerability database? And in the end, spread the effort? How will you do to attract the critical mass of users, dev researchers? Okay, so the first part is it yet another vulnerability database? Well, I think we wish it would be yet another. It's actually the only one we know at this point that contains this kind of information. Unless you consider the MVD one of such databases, which it's not. If you go into MVD, you will have a hard time finding fixed commits. If you did the exercise we did to analyze all the CVs that exist and searching for references to fixed commits, you will find that very few have references to commits. And those commits sometimes don't point to the commit with the code fix, but to commits with the changelog modification. So they are totally useless for our purposes. Other databases exist, but they are proprietary. I could mention probably, well, I would not mention them, but anyway, there are several commercial tools that do have proprietary databases that in practice you could browse on the web, but that's not, as I said in the presentation, that's not the open source way. That doesn't equal being able to use that data in a tool, for example, like Eclipse Steady, which is completely open source. How to attract a critical mass? Well, this is a very good question. This presentation is one piece of the puzzle, we think. I think one way would be to well, this supports Steady in the end. So users of Steady will certainly benefit from Project KB. We hope that the users of Steady will also contribute to Project KB in one way or another. As I said, there are different ways to contribute. Code is one way, vulnerability data is another way. But anyway, spreading the word about this is another way. There are other initiatives that exist, and we are not against, well, we plan to interact with them. Eventually, we might even decide to merge with them. For example, there are European projects that work in this area. There is the Nextbee Vulnerable Code Initiative. There is the Open Source Security Foundation Initiative. They are all sort of related to Project KB. So our goal is to work with them and to come up with something that makes sense for the community. The goal is not to make this for SAP or to make this for just for another project. Hope that answered the question. Okay, I would love to report every vulnerability I fix. I would like to know how can we make CV reporting as easy as possible. Basically, at this point, developer time is very stretched already. I see the value, but if it's not trivial to do, I think people will not play along nicely. Could we auto-generate vulnerability reports from a Git commit message with a tag like security? Yeah, definitely. So, okay, the comment is very important. So indeed, this must be as easy as possible. Already right now, it's pretty easy. If you download KB and you try KB create, you will see that basically you need to just write in that piece of text the URL and the commit identifier of the commit where you fix the vulnerability that you fixed. Of course, it's very easy to generate that automatically from your Git commit log. So we have not done that, but it's a very, very good suggestion. It makes a lot of sense. Some people don't like to put tags like that in their commit messages because that gives an advantage to attackers. So the moment you commit, you make a commit like that, you're basically saying this is fixing a security problem, but you're also basically disclosing the security problem. But at that very time, you have not released yet your non-vulnerable release. So that can give an advantage to attackers. That can be undesirable. I know that GitHub is doing something like creating private branches that are invisible up until the release is issued. So there is some work in that area that is being done also to accommodate this problem. But anyway, the comment of automating the creation of statements is a very relevant one and definitely something that we should look into. Okay. If there are no other questions, I would just use one more minute to say that in the meantime, where the presentation was recorded about a month ago. In the meantime, we have released a revised set of vulnerability statements in the GitHub repository of Project kaybee. There are 720 at this time. The others will come. We just want to make an extra step of quality assurance, so we don't publish the commits we have not completely thoroughly reviewed. And we are also thinking of extending the format for statements to capture other information. For example, the fact that a certain package identified by a peer URL is known to contain malicious code. This is a work in progress, very recent developments. So stay tuned, that will also come. I think that's it from our side. Thanks again for your attendance, and we look forward to collaborate with you.